What we have here is what you also have. This is the foam stability experiment. And we're going to do this now in microgravity. We did it first on Earth and now we're going to do it in microgravity. And of course we're all curious. What is going to happen? These are the same kind of fluids that we have used on Earth. Are the bubbles going to be bigger? Are the foams to be stable? Are they collapsing? And can water mix with oil, for example? Now, we're going to do the first test. I'm going to install it and I will show you how we have the setup here. Here we go. So now in 15 minutes we should be able to determine the differences in foam and foam behavior between Earth and space. Well, 15 minutes later, in tube 1 and 2, we see, well, there are some little air bubbles in the water, which you will not see so much on Earth, of course. If we compare 2 and 3, we can see that in 3, where there's a little bit of soap, there is foam. And after 50 minutes, it's still there. There is no change. And in 4, there's even more soap. And there you see a fantastic amount of foam like you expect, but it doesn't change. So it stays there all the time. The bubbles, the air bubbles stay as big as they are. Now in tube 9 and 10 there is the oil, but we also added soap. Because of the soap you get some foam, and you can see, like on Earth, that if there is more oil, rapeseed oil, that there is less foam. Well, here we see something similar. I think there is a bit less of the foam in tube 10 than in tube 9, but pretty similar. Well, this concludes the experiment, and we have seen some interesting things. We've seen that on Earth the weight, gravity, pulls on the bubbles and makes them collapse. After a while the foam sinks in. You see that small bubbles form big ones, which is a lower state of energy, and then the whole thing collapses. Now in space you don't have that force, and the bubbles stay where they are. Also in the emulsions and the foam nicely stays a foam.